In this video, we are going to look at standard enthalpy change of formation. This is the enthalpy change that occurs when 1 mole of a substance is formed from its elements in their normal physical state at standard temperature and pressure. So, standard basically talks about the STP, the standard temperature and pressure, while enthalpy is heat or energy change of formation. So, formation means producing something. Usually this is denoted by a delta H to show enthalpy change, a theta as a subscript to show, as a superscript to show the standard STP conditions, and then a subscript of F to show formation. So this is how we denote standard enthalpy change of formation. So this is the enthalpy change that occurs when 1 mole of a substance is formed from its elements in their standard physical or standard states. So what do we mean by that? First thing, we have to produce 1 mole of that substance from its elements in their normal physical state. Let's look at an example of aluminium oxide. So we want to produce aluminium oxide as our substance. All we need to know are the elements that make it up. They are basically aluminium and oxygen. So we shall have to get aluminium in its standard form, which is as a solid, and oxygen in its standard form at STP, which is a gas. Remember, standard temperature, we are basically dealing with 25 degrees Celsius or 298 Kelvin, while at standard pressure, we mainly mean 1 atmosphere or 101,325 pascals as our pressure. So, if we want to find the enthalpy change of formation of aluminium oxide, we have to ensure it's 1 mole and coming from the respective elements in their standard form. Aluminium as a solid, oxygen as a gas. So for us to form 1 mole, we have to balance with these fractions 3/2 and a 2, so that we can have 1 mole of aluminium oxide. So enthalpy change of formation of aluminium oxide is minus 1676 kilojoules per mole. These values are obviously got from sources where they have been kind of saved, because scientists tried to note them down and somehow archived. So the second example is enthalpy of formation of calcium oxide. The elements are calcium and oxygen. Their standard forms: calcium is a solid at STP, oxygen is a gas at STP. So for us to form 1 mole of calcium oxide, we need to balance this equation with the fraction here. And the enthalpy change of formation of calcium oxide will be minus 635.5 kilojoules per mole. So here we are looking at how certain substances are formed from their elements in their standard forms. So we have our half here, so that this is balanced. So lastly, we can have a look at formation of benzene, enthalpy change that may occur when we are forming benzene from carbon and hydrogen. So our carbon in this case, maybe it's graphite and it's a solid at room temperature and pressure. And we have one mole of benzene that has to be formed, but from hydrogen. So for us, we have to balance the left hand side so that we get 1 mole of benzene. So we shall put here 6 and a 3. And the enthalpy change of formation of benzene will be positive 49 kilojoules per mole. We shall see that most of them are actually negatively charged, but in this case even endothermic reactions can occur. So one thing to note is that the more negative the value of the standard enthalpy change of formation, the more stable the compound will be. Usually a negative value denotes exothermic reaction, that heat has been given off, and once energy is given off, it means that the new compound formed is at a lower energy level, and that means it is more stable. Usually things that have less energy are more stable. So the more negative the value is, that means the more stable the compound will be. So when you look at these three equations, you'll find that these first two are more stable compared to this last one, which is positively charged. However, the first one is also more stable than the second one because this is more negative than the one for calcium oxide. And the positive value of enthalpy of formations indicates that the compound is likely to be thermally unstable. Usually if something is positive, for example, enthalpy of formation of benzene, positive 49, this will show that this reaction is endothermic. The product is at a higher energy compared to the reactants, and as such, it's likely to be thermally unstable because it has a lot of energy. So, the more negative, the more stable the compound is, the more positive, the more thermally unstable it will be. And forming it will be a challenge because energy has to be provided. So one thing to note is that enthalpies of formation of substances are usually negative. However, they can be positive like we have seen with benzene, but they are usually negative. And for us to determine them experimentally, we normally use indirect methods like the Born-Haber cycle. We shall look at it, but I already have a video at least about its introduction. So you can use Born-Haber cycle to determine enthalpies of formation of most of these substances. So we have seen enthalpy formation of substances. What about formation of elements? Formation of substances, we saw that we are forming them from their elements in standard form. What about if we are forming elements at standard conditions? So enthalpy of formation of elements at standard condition is considered to be 0. Since no heat change is evolved when an element is formed from itself. So, for example, we are forming an element of copper from itself in the same physical states. Obviously, the enthalpy of formation in this case has been considered to be 0. This is essential when you will be calculating different calculations whenever you are given a problem. You have to always know that the enthalpy of formation of elements in their standard conditions is always equal to 0. Secondly, you can look at sodium. Forming sodium from sodium in the same states as solids will be 0. If you are forming oxygen gas from oxygen gas, the enthalpy of formation will still remain 0. So elements at standard conditions, their enthalpy of formation will always be 0 because no heat change is evolved when an element is formed from itself. Feel free to try out the following questions and let me know in the comment section. Try balancing equation A such that it can give us this enthalpy of formation of ammonia. And then lastly, let us know which of the two products in A and B, ammonia and benzene, is more stable and why do you think so? Thanks for watching. Don't forget to like, share and subscribe so that you don't miss any of my new uploads. Stay safe.